All right, so let's talk about color vision. Okay, so the basic colors that we can process are red, green, and blue. Now, this is light that we're talking about. If you've taken art and you've learned how to mix pigments, that's a different process than what happens with light. With pigments, it's a subtractive effect, so when you mix yellow and red, you get orange in a way that's not exactly right in light. The mixing of pigments, you put everything together, you end up with black. In light, you take everything away, you end up with black. You put everything together in light, you end up with white. So we're talking about light when I'm talking about this, because whether we're talking about pigments or light out in the atmosphere, your eyes can only collect wavelengths of light. And so it's either being reflected off of pigments or it's actually out in the world being reflected off of plants and people's hair and whatever you're looking at. So we've got our red, green, and blue as our basic colors in light. Now we have different theories that explain different aspects of how we see color. The young Helmholtz Trichromatic theory says that there are actually 3 different types of cones. One that processes red, one that processes green, and one that processes blue. And that the combinations of these individual cones can produce the secondary colors like oranges and yellow and things like that. So young Helmholtz says that there are 3 types of cones that mix together. Now that explains some aspects of vision, but it doesn't explain things like color blindness, or what's really more appropriately called color deficiency. As you look at these 2 panels, if you have normal color vision, you should be seeing a 45 in the top panel and a 74 in the bottom panel. For some people, the ability to distinguish green from red is not as strong, and so they may have difficulty detecting the numbers at all in the top panel. In the bottom panel, they may detect a 21 instead of a 74. If you look at the bottom panel, you'll notice that so you got basically reddish balls, of different intensities. And then the 74 is made up of some bluish tinted balls and then some that are more greenish tinted. And the greenish ones are the ones that would be hard to distinguish from the red ones. Why would that be? If it was the young Helmholtz theory, we can't really account for why the green is hard to distinguish from the red in a person who has red-green color blindness. But the opponent processing theory correctly explains this. What they say is that we have some light processing cells that deal with white versus black. We call those rods. And then we have some that deal with yellow versus blue cones, and some cones that deal with red versus green. And then in a person who has color blindness or color deficiency, the most common kind is red-green. And what's happening is that the red-green cones are blending their message, so that when they're provided with red stimulation, they fire in exactly the same way as they do when they're provided with green stimulation. Now, what that firing is and how it's interpreted by the person's brain can vary. For some people who are red-green colorblind, they see both red and green as red. For some, they see both red and green as green. And for the more common pattern, they blend the 2 colors together and end up perceiving them as brown. So the opponent processing theory does do a better job of explaining color blindness and exactly how it works. And people who have yellow-blue color blindness have the exact same issue. We now think that the cones that dogs have must be red-green colorblind, and that they have some yellow-blue processing. And we know that by, first off, they were able to discover that dogs do have cones. And then second off, dogs can tell the difference between yellow and blue items. You can reward them for picking the yellow one and not reward them for picking the blue one. And dogs can learn that. They really can't learn red versus green. It's like a random process for them. They just sort of grab whichever item it is and can't figure out what they're being rewarded for. That kind of implies they can't see the difference between the two items. Everything else being the same except for their color, they can't tell the difference between the red and the green items. So the opponent processing theory does a pretty good job of explaining color blindness. Now you might be curious, how does one get color blindness? It's carried on the X chromosome, and so it generally is passed down from your parents on the X chromosome. Mom is much less likely to be colorblind, but to be a carrier of color blindness, because it takes if you have one X chromosome that's coded for color blindness and another X chromosome that's not coded for color blindness, nature will select the X chromosome that has color vision. As genes are being turned on and off through epigenetics, the one that has color vision will be selected for. So she might be carrying an X gene that could cause color blindness, but she doesn't experience color blindness. Men, on the other hand, only having one X chromosome, they're going to be colorblind if they carry the X chromosome with color blindness. So moms tend to be carriers and will be more likely to have a son who's colorblind than a daughter who's colorblind. I had a student a number of years ago who her dad was colorblind and her husband was colorblind and her son was colorblind, and she was the only person in the group who had normal vision, and her doctor told her her son was colorblind because of her, and she was like, wait, I'm the only one who has normal vision, but because color blindness is carried on the X gene, and dad always donates a Y to a son, mom's the only one who donated an X chromosome. She obviously had inherited it from her colorblind father, because he had to donate his colorblind X gene to his daughter, and her mother obviously gave her a healthy X chromosome that had normal vision, and so she's sitting here, the only one who has normal vision, and the doctor's all, no, it's because of you that your son has color blindness. She's like, what are you talking about? And it was funny because when she told me the story, she didn't say that her dad was colorblind. She said her husband was colorblind. And I said, is your dad colorblind? She goes, yeah. And I go, well, you got it from your dad. She's like, no one had ever explained that to her. How do you not explain that to the mom who you just said you're the reason why your son's colorblind? Anyway, sorry, I digress. Okay, so let's go ahead and stop here because this looks like a good spot to take a break, and we'll come back and talk about hearing/audition in our next segment.